Ladies and gentlemen, ladies and gentlemen, are you ready? Are you ready?
Get ready, dog. Get ready. Get ready.
Welcome, ladies and gentlemen, to looking at the difference between sample means and trying to do both confidence intervals and significance testing with this. If you'll notice here, initially I am starting with two data sets, population 1, population 2. We have population size of 200 for each and respective population means and population standard deviations. So you can look at the two data sets, one in red, one in black. And what we're going to be doing is taking random samples from each and then generating a simulated difference of sample mean, sample distribution. So you notice one of my sample sizes is a sample size of 8. The other sample size 12. So they're not the same sample size. And the other thing to note here is that the initial data is randomly generated from two approximately normal populations. So even though our sample size is not of sufficient size by itself to honor the central limit theorem, since they're drawn from two approximately normal distributions, then the sampling distributions would be approximately normal in shape regardless. So we could draw a sample here, and you can see that I get the mean and standard deviation from that one sample of 12 and another mean and standard deviation from that other sample of 8. And what I have listed over here is the resulted difference between those particular values. I could do this again. I could do this again. I could do this again. Instead of drawing a sample at a time here, we could draw whole groups of samples. How about 100 samples? And another 100, and another 100, and another 100. You start to see a trend after we draw enough of these. Here we are at just over 1,000 simulated samples. And here we have a simulated sampling distribution with more than 1,000 samples of the difference of these individual sample means that we've done over and over again. So you can see we get some differences that are below 0, some differences that are greater than 0. But if we enlarge this a little bit, take a look here, you can see that the average of these more than 1,000 samples for the difference of those means is close to simply the difference of the two population means. We should have an actual difference of about 0.67, and we have a difference here of about 0.66. Very close. What is not so obvious is how did we get this standard deviation? So considering how would we get the standard deviation of the theoretical sampling distribution for the difference of means, we need to consider each of the individual theoretical sampling distributions from each sample mean initially. So we look at the first population where we were drawing samples. We had a mean of that population of 4.86 and a standard deviation of 4.8. If we took repeated samples of size 8 from this population, we would generate a sampling distribution and determine what the shape, center, and spread would be. Now, since the population standard deviation is approximately normal, then even though the sample size is not greater than or equal to 30, the sample distribution will still be approximately normal, centered at the population mean of 4.86, with a standard deviation of our population standard deviation divided by the square root of our sample size. So that's going to be 4.8 divided by the square root of 8, which is about 1.697. With our second theoretical sampling distribution, we had a population mean of 4.19 and a population standard deviation of 5.8. So when we took repeated samples of size 12 from this population, we could determine our shape, center, and spread once again. Since this population itself was approximately normal, even though we don't have a sample size greater than or equal to 30, this new sample distribution will still be approximately normal, centered at our population mean of 4.19, with the standard deviation of determining standard deviation of that sample distribution will be our population standard deviation divided by the square root of our sample size. So for this one will be a standard deviation of 1.674. So the real question is, how do we determine our shape, center, and spread of theoretical sampling distribution where we're looking at the difference of these two? So when we consider what is the shape, center, and spread of the sampling distribution for the difference of sample means going to look like? Well, since both of the repeated samples were drawn from populations that were approximately normal, even though their sample sizes were small, this sample distribution will be approximately normal. The center for the sample distribution of the difference of sample means is simply going to be the result of the difference of means from those two individual sampling distributions. So the sample distribution of the sample means for the first population will be centered around 4.86. Sampling distribution for sample mean of the second population will be centered around 4.19. And so the mean of this new sample distribution for the difference of the sample means will be simply the difference of those means, or approximately 0.67. What about the spread for the difference of sample means? Standard deviation for the sampling distribution of the difference of sample means. Now if we remember from before, when we have independent random variables, we cannot just take the difference of the standard deviations or even add them together. What we actually have to do is find the variance of each, add those variances together, and then take the square root. So the standard deviation of the sampling distribution for the difference of two means is really going to be the square root of the sum of the variances divided by each of their respective sample sizes.